This section describes an example of targeting system implemented using uFrame. This is an advanced tutorial, so to get most of it, you should be familiar with the basics of uFrame. We will mention such concepts as scene properties, computed properties, commands, and view components. And let's get started. Here is how the example looks like. On my triangle, I got a Boolean property called AutoTarget. Once it's on, you can see this yellow line representing my target. Also, I got a scene property called DistanceToTarget and a computed property called isTargetCloseEnough. For now, my targeting system does nothing more than picking up the closest square. Everything happens dynamically, and once I move my squares around, a new target is acquired. So let's see how this looks like inside. This is how my diagram looks like. I got those guys called triangle and square. My square is quite simple. It only has an avatar position, a vector3 property, and this is how it's implemented. Nothing that much special. My triangle guy is a bit more complex. It has two regular properties called target of type square and AutoTarget of type Boolean. It also has a scene property called DistanceToTarget and a computed property called isTargetCloseEnough. Finally, it has a command called setTarget, which brings a square as a parameter. On my view, I also got this binding called AutoTargetChanged and a few view components, which I will explain in a second. But there is one very special thing about this target here, and I will do my best to explain what it is. Imagine that in your game you will have another element. Let's call it RTSRoot. This guy will be responsible for keeping track of all those units in your game, like triangles and squares. Most probably it's going to have a collection of triangles and a collection of squares. And of course, it will be responsible for creating those objects. So it may have a command, something like create triangle, for example. And of course, all the triangle views and square views will be instantiated in the context of RTSRoot view. So we can say that this RTSRoot kinda owns those instances. And this is a very interesting point of view, ownership versus referencing. As an example of referencing, look at my target property right here. It has a reference to the target, which is square in our case. But it does not really own the instance. In the beginning of your game, you will have no target. Later, you can set up the target using the setTarget command here. But at this point, the instance of target will already exist in your game. So we can say that triangle references the target, but does not really own the instance. Advanced users may define target as a scene property. Indeed, we cannot calculate the value without the game loop running. But on the other hand, if we set target as a scene property, we then have to expose our target validation in the view. And moreover, our target may not only come from the view. In fact, our RTSRoot may tell all the triangles which square to target. All those issues are addressed with this little setTarget command here. We can put our target validation logic inside this command and let both view and other sources of logic use it in order to change the target of this particular triangle. Finally, we can introduce this AutoTarget Boolean, which will turn on and off the targeting capabilities of the view. And this is awesome because now triangle does not really care where the target comes from. It just says, give me the data. Time to look at the code now. This is my view model, and you can see I got compute isTargetCloseEnough method here. Indeed, all the computeds now are calculated inside the viewModel object. In this case, it's nothing more than just comparing two numbers if the target is not null. In my controller, the only thing I got is the setTarget command, which is again pretty simple. I just do assignment here. Finally, meet the view. Some of those things should be familiar to you. Look at this calculate distance to target. If my target is not null, I return this distance, else I return 0. Notice how I use triangle.target.avatar position. In the update method, if my target is not null, I draw a yellow line from my current position of the triangle to the triangle.target.avatar position. And as I have already mentioned, we got AutoTarget changed binding, which is a little bit tricky. Look, whenever my AutoTarget is set to true, I bind the property here, and this binding is disposed when triangle.AutoTarget property is changed, which is exactly this one. Obviously, the next time AutoTarget changes, the value is going to be false. That is why the binding here is disposed and my target is set to null. What's strange about this binding property call is that I use some strange property here, targeting strategy.last target property, and whenever it produces a new value like this target, I execute my setTarget command using this one. But where does this property come from? Well, here I got my view component called targeting strategy. So let's take a look at it. This is my targeting strategy. As you can see, everything here is dancing around this P property. P properties are cool. They are properties and they are observables at the same time. So I got this private guy here, which is exposed using this public property called last target property. This is why, from my view, I can bind to it using this .bind property. Also, I got this little shortcut here, which does nothing more than getting the current value of the property. And this is exactly the pattern which is used in the view models, except in the view model, you also pass the owner and the name of the property when you create it. So hopefully you can see that if you cannot express something using the diagram, you can easily code it yourself. In the update method here, I invoke my findTarget, cache the returned value, and just set my property to this value. And if you look closely, my targeting strategy class is abstract, as well as my findTarget method. So I let my concrete implementations to solve finding target problem for me, just like it does the closest first targeting strategy. As you can see, it just absorbs all the squares around, selects the view models, and returns the first one. Well, of course, they are ordered by the distance. And that's kinda it. So now we have a very solid system with decoupled logic for every single property, targeting system, and anything else you can come up with most probably. The targeting logic is encapsulated inside concrete implementation of targeting system. And this is a good place to provide integration with third-party solutions. If I want to change my targeting timing, I can simply change my targeting strategy base class here and, replace this ugly update method with something else. View is completely independent on where the target comes from because it uses the avatar position rather than some sort of a view. So my scene property is independent and my update method here is independent too. And moreover, my view can turn on and off my targeting capabilities.